We'll be talking about the interior angles of a triangle. Our goal will be to find the measure of angles that involve triangles, particularly the interior angles. So we'll start off with a couple examples here. And a theorem, the triangle angle sum theorem. Let's remember that the sum of the interior angles of triangles is 180 degrees. You probably remember that from probably 5th grade. But what that means is if I add these three angles together, they will equal 180 degrees. So if I start with 91 degrees and I add that to 62 degrees and then x degrees, that will equal 180 degrees. So just like algebra, I can combine my like terms. Let's see, that'd be 153 plus x equals 180. Then I can subtract 153, and I would get x equals 27 degrees. So pretty simple there. You probably remember the algorithm from when you were in like 5th grade of add the two angles and subtract from 180. But notice I wrote it out this way to show you this is how it works, this is why it works, which is going to be helpful as I look at the next example where I'm adding my angles. And this time they are not just numbers. I'm not just looking for x. But I'm going to find x and then plug it back in as well to find the angle, kind of like I did on the first example. So let's see. If we add our three angles together, again, it's a triangle, so they would equal 180 degrees. So I'm going to start with 90 degrees because angle A is 90 degrees. Then I'm going to find angle C, which is this one, 8x plus 4. Again, I put it in parentheses because it's one angle. It's a group together there. Then I'm going to add angle B, which is this one, 18x plus 34. And from there, I will say that that equals 180 degrees. Again, those three angles added together equals 180. Notice the 90-degree angle, angle C, and angle B. So we add these together by putting our like terms together. 8x plus 18x would give me 26x plus 94 plus 34, which is 128, equals 180. We subtract our 128. We get 26x equals 2 and 5. So 52, and we divide by 26, and x will equal 2. We don't stop there because the question asks us to find the measure of angle ABC, which in this case is just angle B, which is right here. So the measure of angle B is 18x plus 34. We're going to plug the 2 in, so we get 18 times 2 plus 34, which will give us 36 plus 34, which will give us 70. So this is the measure of angle B, 70 degrees. So pretty simple. Your three angles inside of a triangle add together to give us 180 degrees. Don't get mixed up thinking any of the angles that are outside would confuse you there. Let's look at a couple of examples now, or at least one where we'll have a triangle that deals with an angle outside the triangle. So notice the triangle. Let's say that this is 110 degrees. Let's say that this is 120 degrees. And let's find this angle over here. So first things first, this is a straight line. So I'm going to say y, just for the sake of picking a variable. 120 plus y would give me, anybody know? 180, because it's a straight line. Subtract from 120, and y will give me 60. So with this being 60, now I've got 60 plus 110 plus z, for the sake of picking another variable, will equal 180 because that's the interior angles of a triangle. 60 plus 110 is 170 plus z equals 180. subtract, and z is 10. From there, z plus x, let's see, 10 plus x would equal 180, so x would be 170. So sometimes your triangles will have these exterior angles out here, but still pretty simple because a straight line is 180 degrees. So this plus this is equal to 180, just like a triangle. Which leads me to the last thing I want to show you today. When we talk about triangles, let's look at a triangle. This is a triangle. Notice I just cut the corner off of a piece of paper to make my triangle here. Y'all are pretty used to having this, and you're pretty used to seeing that this and this and this add together to give me 180. So that's not new to you. Kind of hard to see my lines there. Let me see if I can make those a little darker with a pen. Yeah, there we go. So there's our angles. These are the three angles of a triangle. Y'all are pretty good at noticing that these three angles have a sum of 180. But sometimes I don't think students make the connection that that's the same thing as a straight line or a straight angle. A line is always straight, so sometimes we refer to a line as a straight angle. So what I want to do here is I want to tear each corner. I don't really care where. I'm just going to tear off each corner, okay? And I'm going to place them together. So there's one corner. There's a second corner. And there's a third angle. And I'm just taking that middle part and throwing it away. But if I take these three pieces and I put them together, they will form a perfect straight line, or straight angle as you may call it. And that's just a simple demonstration to see a connection between a straight line and it equaling or having a sum of 180 degrees and a straight line and the interior angles of a triangle equaling 180. The only other thing they can throw at you is if you have vertical angles, and if you don't remember vertical angles, real quick I'll demonstrate. If two lines intersect, the angle and the other angle that are across from each other are congruent. Those are what we call vertical angles. Those are the only tricks you should need, and you should be able to answer any questions somebody throws at you about the interior angles of